So today then we're going to solve rational equations. So we've worked with adding, subtracting, multiplying, and dividing rational expressions. And today we're going to take them and we're going to solve radical equations. Or rational equations. And so I'm actually going to show you two different things I've kind of thought about as I worked on them a little bit this morning and thought through it a little bit, that I'm going to show you two different methods in this process. Okay. First of all, one of the things is, since we're working with fractions, how many of you really don't like fractions? You don't need graph paper, okay? Yeah, Tom. Okay. So we don't really care for fractions. So since we don't really care for fractions, then what we'd like to do is get rid of them as soon as we can, right? Goodbye, fraction, go away, so I don't have to work with fractions. So what we're going to do to get rid of the fractions is we're going to multiply by the least common denominator to be able to get rid of it. What we're going to do is we're going to do something to both sides of our equal sign to be able to get rid of them. So when you look at these equations that have denominators, what you want to look at is what would be the common denominator if I needed one, or the least common denominator. So in this case, how many different denominators do I have? We have two? What are they? X and 1. Good. All right. So my common denominator then, since I have two totally different denominators, my common denominator would be 1x. So what I want to do then is, to get rid of the fraction, I want to multiply everything by that common denominator. So I'm going to multiply x by it, negative 18 over x, and 3 by it. Okay? So we find the common denominator. And multiply everything by it. I'll run out of room. Now, what that allows me to do then is to eliminate the denominator. So x times x gives me x squared. But look at the second fraction. I have 18 over x times x. What happens if I have x in the numerator and the denominator? Then they're going to cancel out. So my second term here is just going to be negative 18 then. And equals 3x. So I just got rid of my denominator. Okay? Don't like them, gone, got rid of it. Okay? So by finding the common denominator, or the least common denominator, and multiplying everything by that, I'm able to eliminate the denominators, and I just have to work with whatever equation I end up with then. Okay? So what do I do next to solve this equation? All right. So we have a quadratic equation now, right? Okay. An equation that has x squared. So that means we want to get everything on the same side, so hopefully we can factor to find our answer. So we're going to subtract 3x from both sides. close. So it was close. All right, so I have a quadratic equation now equal to 0. Can I factor this? What are the factors of 18 that when I subtract I get 3? Okay. 3 and 6. So the 6 is going to be negative and the 3 is going to be positive. So x equals 6 or negative 3. Now, what's the one thing you should always do when you solve equations? Okay, check it. Now, also the thing is that do you know that every equation you run across, you could actually find the answer with your calculator? Okay, all right. Okay. All right, so we're going to go through that and take a look at it, all right? But you're still going to need to do this algebraically, but I want to remind you that when doing a standardized test, multiple choice, sometimes it's easier just to plug things in your calculator, find the answer, than actually do the grinding through all of the stuff for it. But you have to check your answer. So if that means doing it by hand, where I put 6 in for x, and checking to see if it's correct, right? So you should always check, or if that means taking my calculator and doing it there, right? Which I did right here. Negative 3 minus 18 divided by negative 3. But I could verify my answer for sure here. What do we have? X minus 18 divided by x. And I want to know when that equaled 3, right? So I put one side on the left, or one side, the left side of my equal sign in y1, the right side in y2. And I could either go to my table and look to see where they're the same. And I can see they're the same at 6. And at negative 3. Okay. Or I could graph them. Oops. If your calculator works. All right, mine froze. Nice.
Technology.
Great when it works, isn't it? All right, so 18, oops, not 18. X minus 18 over x equals 3. So if I graph it, I can see that the line where y equals 3 crosses at 2 places, and so those 2 spots would be my answers. Okay. All right, so let's look at one more. I want to look at letter B here, because I want to, let's just look at letter B. All right, so if I want to solve this one, what am I looking to do first? Okay, we want to find the common denominator. So I look at my denominators. Are they completely different? If they are, then I'm going to multiply them together. Okay? So in this case, my common denominator would be 4x. So I can multiply everything by 4x. So the nice thing about multiplying by the least common denominator is it allows me to cancel things out. So I can, so I've got x here, I can cancel those out. 4 here and a 4 here. 4 here and a 4 there. It allows me to get rid of all of the denominators. And so for those of you who don't like fractions, I don't have them anymore. 4 times 6 is 24, plus 5x equals negative 7x. So I've got rid of my denominators. So now I have an equation that I'm much happier solving. So I subtract 5x from both sides and then divide by negative 12. Now, can anybody see a different way I could possibly do this problem? Because there's actually something unique about this problem that I could actually do it a little bit differently, and for some of you, you might even actually prefer it. David? What's that? I can't at this point in time, right? But you're on the right track. So what would I have to do to be able to cross multiply? Okay. Since the 5/4 and the negative 7/4 have a common denominator, I could actually get those two together to start with. So I could subtract 5/4 from both sides first. So we would get 6 over x equals negative 7 minus 5 is a negative 12 over 4. So now I just have a proportion that I could solve it just by cross multiplying. So sometimes if you have a common denominator, it would actually be easier to simplify it first. And if you have a situation where you just have a proportion, I could cross multiply. Get the same answer. Right? Just a thought. Okay. All right, let's look at, we got just two other examples we're going to look at. We're going to talk about something called extraneous solutions also. And if you don't remember what those are, that sometimes when I solve equations, I get answers that work when I do the solving, but when I check my answer, they don't work. So it's important that you check your answers to make sure that everything works when you plug it back in. If it doesn't, then you have an extraneous solution, which means that that is not a solution at all. Okay. So, this problem here. 5x over x minus 2 equals 3x plus 4 over x minus 2. What can I do to solve this? Okay. So get it equal to 0. Okay, so one of the things we could do is we could subtract one side and get it all on one side and have it be equal to 0. Okay, that's one option we could do. What's something else we could do?
We could cancel.
What do you mean by cancel, Tom?
Cancel all x's and stuff. No?
Do we have common factors that we can do that with?
I don't think so.
I don't think so, because in the denominator we have x minus 2. Do we have any x minus 2's in the numerator? No, so we can't just cancel then. Okay. Okay.
Cross multiply.
Okay. We could cross multiply. All right. That's something else we could do. All right. But in this specific problem, I want you to think about something else. Okay. Do you remember when we did these problems that look like this? Or when we did the problems like this? What did we do with those problems? Because this problem here is kind of like those two. Anybody remember what we did there? Okay, we did combine them. But the thing was is that with these problems here, what was really nice about them is that we had the same base. So we said the exponents were equal to each other, right? In here, we had the same base. So we could say x plus 1 equaled 3. Same type of problem here. So sometimes you have to see what's going on. And hey, my denominators are the same. So that means that the numerators have to be equal to each other. Could I get the same answer by cross multiplying? Certainly you could. It's just going to become it's going to be a little more difficult in this case. So then we subtract 2x or 3x. So we get 2x equals 4. So x equals 2. Now, we know that when we solve equations, we're supposed to check them, right? So that means we need to put 2 in there for x. So we check our answers. We get 10 over, what's 2 minus 2? 0. Hey, they're the same thing, aren't they? Yeah. So does 2 work? Why not, David? We can't divide by 0. Because we cannot divide by 0, then 2 cannot work. And so my answer is no solution. It's called an extraneous solution, a solution that we got when we solved the problem, but when I put it back in, it does not actually work. And so if you were to put the left side in your y equals in y1, the right side in y2, to see where those two lines intersect, they are not going to intersect anywhere because there is no solution to this problem. So those two lines never cross. Okay, we'll do one more. Okay. First thing, Look at your denominators. How many different denominators do we have? Okay, we have 2 different denominators. Now, one thing that I forgot to mention, and we didn't have a problem like that, but the first thing you should always do is if you can do any factoring, do factoring as far as the denominator goes. Okay? So sometimes the numerator helps too. But any factoring you can do. All right, we have 2 different denominators, x minus 8 and 2. So the combination of those 2 together is going to be my least common denominator. So I want to multiply everything by 2 times x minus 8. Each individual fraction I'm going to multiply by my least common denominator. Because what I've done is I've multiplied both sides by the same thing. That means then that this x minus 8 and this minus x minus 8 are going to cancel. This 2 here are going to cancel. This x minus 8 and that x minus 8 there are going to cancel. So we get 2 times 2x minus 5 plus x times x minus 8 equals 11 times 2. Okay. So the x minus 8's canceled. So I have 2 left multiplied by my numerator here. The 2's canceled. So I have x times x minus 8 because it's still there. The x minus 8's canceled, so I have 11 times 2. Now I just end up with a quadratic equation that I'm going to need to solve. And so we're going to go through this whole process here. All right, so I'm going to do my distributing. And then simplified the left side. So we're just doing some basic algebra here then. So we have a quadratic equation. So we need to get everything on the same side. Okay, nice thing. Got it down to a quadratic equation that we can factor. All right, Kylie, what do we get when we factor it? Okay, x minus 8 and x plus 4. Now, okay, we get 2 answers here, right? Positive 8 and negative 4. That's wonderful. Okay? The only thing is that if I go back up here, that I notice something. That I have, oops, I don't want that color. X minus 8 in the denominator, common factor x minus 8 down here. Okay? So when I put 8 in for x, what happens in the denominator? Okay. We get 0, which means that we're going to be dividing by 0 there, and we can't divide by 0. So 8 is an extraneous solution, does not work. So my answer is just going to be x equals negative 4.
But so why doesn't it work for
Because when I put it back in here for x, I get 0 in the denominator. And you can't divide by 0. Okay. And you could put this in your y equals to check it. All right? But it's important you do check your solutions to make sure they work. In these cases, most often it's going to be, all right, since I'm working with denominators, does it work with my denominator? All right?